Okay, I haven't seen you guys for a while, so I'm going to try to videotape this and do the best we can. And I'm out this week, and I apologize. So, if you're on your packet on page 10, I'm going to read the instructions for that. It's actually on page 26 on your in your book, but it says on a 5 by 5 dot grid, draw line segments with as many different lengths as possible by connecting dots. Label each segment with its length. Use the square root symbol to express lengths that are not whole numbers. Hint, you will need to draw squares that extend beyond the 5 by 5 dot grid. So when we're talking about the 5 by, oops, I don't want that. Need the toolbar. Okay, when we talk about the 5 by 5 dot grid, this is just the green part. So your lines have to be within that green area. However, when you make your square, they might extend out into the other areas. So when you do this, you can do your straight on, that's an area of 1, right? 1 square centimeter, so the side length would be 1. Then you can do your 2 by 2 square, and that would be 4. And the 3 by 3. But what I want to talk about is these diagonals. You're going to have to make some that are diagonal. So for this one, you go up 1, over 1, and then the slope is 1. Oops, it disappeared. I didn't want it to disappear. But anyway, so you're going to have to draw some of these diagonal and find the area of the square. And this area of the square is 2, so the side length would be the square root of 2. Because that's an exact number, and we'll talk about that in a little bit. But here, like, you would want to go, you went up 2, over 2, so go down 2, right 2, put your dot and connect, down 2, left 2, connect, and then you're going to have your nice square. Right? And you're going to have to square up and subtract. So let's get a different pen here. It doesn't disappear on me. Let's go with pen, much better. All right, so we learned that perpendicular lines have slopes that are negative reciprocals of each other. So if a slope is 2/3, the opposite reciprocal would be negative 3/2. So if I have this point here and I go up 2 and over 1, 2, 3 and put my point, then I'm going to connect that line. Now, meaning perpendicular lines form right angles and squares have right angles. So if I want my next slope, the line has to be perpendicular, so I'm going to go down 3, 1, 2, 3, and over 2 and put that point. All right. And then I need another slope of 2/3, so down 2, over 3, and connect that. And that's how you get squares. And then you have to decide the area of the square and the square root. So you'll see some of them will go out. So I say start with up 1 over. Well, let's go up here. Up 1 over 1 can be your first. Up 1 over 2. Then you can go up 1 over 3. These are the lines you can do. Up 1 over 1, 2, 3, 4. All right. So and then you can square it up. So try to do as many as you can. There's actually 14 of them, including the ones that are straight on. I think you guys can do that. All right. So now we're going on to some vocabulary before we get into the next lesson. So some of you, and you should have this worksheet, some of you are not quite sure how to read this. And this is read as 9 squared. Well, what does 9 squared mean? It means 9 times 9, which is 81. The next problem is the square root of 9. Right? And that means what number multiplied by itself equals 9? And that answer is 3. Now remember, not all numbers are perfect squares. So we can't always come up with an integer when we take the square root. So this next one on your paper is, you're going to write it as 2 squared, which means 2 times 2, which of course is 4. Right. This one's read as the square root of 2, which means what number multiplied by itself equals 2. And that's as good as it gets because that is an irrational number. It doesn't terminate. It's going to go on and on and on forever. So that's an exact answer. So sometimes, for instance, if the area of a square, pretend I can draw, if this area of the square is 2 square units, well, if you know the area, to get the side length, you take the square root. That's an exact answer for the length of that side. If I want an exact answer and it's not a perfect square, you're going to have to leave it under the radical. Now, if I want to estimate what that is, so my estimated answer is going to be like 1.3 centimeters or whatever. Because I know the square root of 1 is 1, and the square root of 4 is 2, if you're looking at your IMB. So the square root of 2 has to be somewhere in between 1 or 2, a little closer to 1. So let's go to the next. So what I want you to do is find the exact side length of each square given the area. So here's an area. Here's a square that has 1 square centimeter. So the exact side length, you always take the square root of the area, and this equals 1 centimeter, because 1's a perfect square. This, you can see, has 16 squares, so 16 square units. I want to know the length of one side. You could count it, but it's really going to be, and gives you the same answer. So if I know the area, I take the square root to get the side length. And that's an exact answer because 16 is a perfect square. Let's look at this square here. This is a tilted square. This area is 1. The area of this triangle is 1. So this has an area of 2 square centimeters. So to find the side length, I have to take the square root of 2. And guess what? Square root of 2 is an irrational number. So I leave it. The exact answer, the square root of 2 stays under the radical. All right, square root of 9. So then that would be square root of 9 centimeters. 9 is a perfect square, so that answer would be 3 centimeters. Let me extend the page if I can. Okay, well the next one, why don't you do? That'll be a good one. I'll have you do the next one and then turn off the video or pause it and see if you can figure out number 5, what that area is, box it up and square it. Turn the video off or pause it. And, all right, so now you should have paused the video. And you should have found that the area of that square is 13 square centimeters. So the side length is the square root of 13 centimeters. Exact. Now, this one says estimate the side length if applicable. Well, I don't have to estimate if it's an integer answer, 1 centimeter, 4 centimeters, 3 centimeters. I do need to estimate if it's an irrational number. So I'm going to estimate this side length to be about 1.4 centimeters. And you're not going to all have the same answer, and it's not going to be exact, and that's okay. Well, the square root of 13, if that's the side length, well, let's see, the square root of 13 is in between 9 and 16. It's a little closer to 16, so the square root of 9 is 3. The square root of 16 is 4. Oops, so I'm going to say this is going to be about 3.5 centimeters. I don't know, maybe 3.51 centimeters. There you go. So remember, if the side length is, to Get the side length. If you know the area, you always take the square root of the area to get the side length. Sometimes, though, your side length is going to have to be left under the radical if I want an exact answer. Okay, so now you are going to go to your book, page 33. I want you to read page 33 in your book. Oops, I take that back. Yep, 38. Read page 38. In your LFP book. Right. That gives you some vocabulary. And then you're going to, I sent you a link. Right. One of many I'm sending you. That helps you fill in the yellow packet. Page 15. So go ahead and do all that. If you happen to finish early, there's that quizzes, excuse me. There's 2 that quizzes to do. When you can. It's in classwork, that quizzes. And then there's also problem solving you can do. Remember, you got to do 5 problem solving before the end of the marking period. And you have to do the first 3 that are over there. All right, hey, please be really good for the sub. All right, I appreciate it, and I will see you. Gosh, I won't see you guys again till next Tuesday. Have a good one.